What ratio did you use, and what was your final answer rounded appropriately? 19. What ratio did we use? Sine ratio. And x was equal to what to the nearest foot? 12 feet. Nice job. Anybody want to talk about that one? Sine. Next one. Which ratio did we use? Here we go. 13. Tangent. And rounded to the nearest foot, we ended up with 14 feet. Anything? And then yes, I did design it on purpose this way for number 3. That you used 11. Cosine with a final answer of x equals 19 feet. What is that? All right. We okay. Fine it aside. All done now. Because now, take a look at what's new. What am I asking for now? On the next problem, I'm asking for an angle. All right, I'm asking for an angle. I know the sides already. All right, I am not going to change anything yet. So I want you to go through the same process we've been going through. Look at the acute angle x. Tell me what the 12 and the 24 represent. All right, the 12 and the 24. We're not going to change anything yet. So here's my acute angle. What's the 12 and the 24 represent up here? Here you go. 8, what's it represent? For which one? For the 12 and for the 24? Perfect. Which means what ratio is in play now? 15? Cosine, yep. All right, here we go. Cosine. How would you set up your usual equation? Cosine of x. Okay, it's x now instead of an actual degree measure. We got to find that degree. Equals, what ratio would you set up if we're using cosine now? 17? Just looking for the ratio. Which would be what in our case with actual numbers? 12 over 24. So here's what we're looking for. What angle has a cosine ratio of 12 over 24? I have no idea. But you know what does? Your calculator. But here's the problem. The sine, cosine, tangent buttons only work when you know the angle. And you can plug in the angle. I don't know the angle. So instead, what I'll use is, everyone see above it, -1 as the exponents. This is called the inverse of sine, cosine, and tangent. The inverse. So if I know the ratio already, I am not going to cross multiply. All right? I know the ratio. I'm trying to find the angle. To find the angle, I take the inverse of whatever ratio I'm using, in this case cosine, and use the 12 over 24. No cross multiplying when I find an angle. So I go to my calculator. Second cosine, what do you think it wants me to plug in? The adjacent over hypotenuse ratio you found. 12 over 24. You can do a division symbol if you want. You can also do your fraction template. It's your call. So your calculators, you're telling the calculator the ratio is 12 over 24 for cosine. What angle has a ratio of 12 over 24? 60 degrees. So x equals 60 degrees. All right, so anytime you know the ratio and finding the angle, I want to use my inverse ratios instead. All right, and that's exactly what this is saying down here. So 1 doesn't make us great. Maybe 2 will. There's your acute angle. What's the 12 and the 18 now? 12 and the 18. Here you go. 5, 12 and the 18. Got it? So I should be using what ratio in this problem? 4? Sine, yep. Sine of x equals opposite 12 over hypotenuse of 18. Now let your calculator do the work. What angle has a sine of 12 over 18? What angle has a sine of 12 over 18? One, when you get there, let me know. 30, 42 degrees. Got it. Any questions from you guys? Yes, Letty? You can if you want, yep. All right, you'll find out if you plug both in that they'll be the same degree measure. Yep. All right, I want to see you do 2 on your own. And you'll notice one is finding an angle, the other is finding a side. All right, I want to make sure you can handle going back and forth easily. All right, so go ahead and do number 3 and 4. Take your time. Again, 3, you're finding an angle. 4, you are finding a side. And then you plug in. Change it. Didn't you already permanently change it into? Yeah. Yeah, we're never going to be working with that for, you won't need that at all. Okay. All right, here we go. Problem number 3. What ratio did we use? 5. What ratio did we use? Yes. Tangent ratio. Perfect. With a final answer of degrees. Got it. Now find a side. Which ratio did you use here? 15. You're darn right you did. Cosine. With a side length of 7. 14.0 centimeters. Yep. Whew. Questions? So this one you just used cosine. This one you did second tangent. All right. Questions? All right, I am going to skip over this rectangle problem because I think you could do it on your own. And I am going to go right to this next one because the directions are a little bit different and I need to explain them. Going to make a couple enemies here if I haven't already. Solve the right triangle. Any ideas what I'm asking when I ask you to solve it? Michelle? Yeah, everything. Everything that's not labeled, find it. All right, so when you see solve the triangle, that's find all remaining sides and angles. Oh, kidding me? Nope. Find all remaining sides and angles. So 2 angles and a side in this case. 2 angles and a side. What do you want? Do you want to do the side or one of the angles? Go right to the side. Everyone wants to do the side today. Fine. Hey, it's a bad news for you. If you guys want to find the side, sine, cosine, tangents out. Out! Because I don't know any other angle other than the right angle, which I never use. So how can I find that third side? Pythagorean theorem. It's a right triangle. Hey, is that side a leg or a hypotenuse that I'm trying to find? Leg. All right, so a squared plus 21 squared equals 25 squared. Oh, you lucky ducks. Round your sides to the nearest tenth. Should say simplest radical form. Nearest tenth, whenever you get it, number 15. 13.6 feet, yep. Quick class decision, which angle are we going to find? B? All right, B it is, angle B. All right, what ratio do you want to use? You already know the 13.6, so technically you could use any ratio you want. But go ahead, let's pick a ratio, 11.
For angle B?
Yep. Sine, cosine, tangent.
Sine.
Sine, okay. So sine of B. If I choose sine, what two sides are going to be put in the ratio if I have chosen sine? 12, what two sides?
Opposite.
Yep, which would be in what in our case?
13.6.
Over?
Hypotenuse, which would be
25, yep. Finding an angle. So I'm going to be inverse sine of 13.6 over 25 to the nearest degree. 30, 3 degrees. Hey, honors kids, am I going to force you to do another sine, cosine, tangent to find angle A? Because, no, I'm not. No, I'm not going to, because you're honors and know a nice little fact about triangles, which says, what about the degree measures? They all add up to 180, so I could just find angle A pretty quickly and say that is 57 degrees. Remember, you are going from your textbook to your packet tonight.